Okay. Now see the program. Again, the same program. Here, the same program I have taken. Now I'll shift the zeros. The earlier zeros, no zeros in there, only gain was there. Now I zeros shift towards negative infinity. Earlier we shifted pole towards negative infinity. Now if you move the zeros towards negative infinity, what is the effect? Compare the values and give the conclusion. So I'll give here. So you can take the first one, -1, -1 we are putting, and execute this. Execute. So I'll get waveform. So like this you'll get. If you move the zeros towards negative infinity, what are the changes? Note down. Okay. So this is the peak overshoot. So when you zeros, if you move towards negative infinity, peak it's very high. You can compare with this. So compare all values and give the conclusion. Compare and give the conclusion. So this is about when -1. So when -10, what is the values? You can check clearly. You can check here. So this is the -1. So -10. -10 is the value. So -10. See, again it is. Give the values. Peak response, how much? Settling time, how much? Rise time, how much? And compare these values. Okay. So characteristics, that is same values. So I'll compare, note down all this reading in a Tableau column properly. Compare before and after. Give the conclusion properly. What happens when if you move zeros from origin to negative infinity in the S-plane of root locus. Okay. So now again we'll see what when if we go for 100, what happens. So you can see here, this is the graph figure. So again, you measure characteristics, peak response, settling time, and rise time. You can see that. This is values. Take this one, note down. When you move poles from origin to negative infinity, what happens to the system? Give the conclusion. And when you move the zeros from origin to the negative infinity in S-plane, then what effect on the system? Give the conclusion. That is the second part of the experiment. Thank you.